This video is going to be about binary code.
Or, for those of you that speak binary, 0110011001001.
Oh. So binary code seems like a unapproachable, insane, foreign thing that only machines can understand.
Yes!
But not today. Today you will also understand binary code.
Yes! Yeah, so get excited, people! Because binary is a very abstract thing that a lot of people don't know about, even when they work in computers. Mm-hmm. So what is binary code? Well, it's simply just a base 2 coded language. It's not even really a language, it's a numbering system that's a base 2, where we have 2 digits, 0 and 1, where 0 represents off and 1 represents on. And we can use binary to express anything. Numbers, characters, instructions.
Our number system, as you're used to, is a base 10.
Right.
So we go 1 through 10 and then start over, whatever, everything in increments of 10. Actually 0 through 9. And then 10 is 1 with a 0 through 9. And 20 is 2 with 0 through 9, and so on. Mm-hmm. And we use that because it's convenient, because we have 10 fingers.
Right.
And it was easy a long time ago for us to count in increments, so we can, have 5 on a hand, 10 on both hands, and then how many times that is, 10, 20, 30, whatever. So it was a matter of convenience for us. Really, a base 12 is a more efficient mathematical numbering system to use, where we would go 1 through 12, 1 through 12. But 10 is convenient for us. For computers, because they're on-off switches, base 2 is the most convenient. Mm-hmm. So things, as far as a computer understands, is either on or off. So if we take our number system down to a base 2, we just go 0 to 1, and then we start over 0 to 1, 1 with a 0 to 1, and so on, just like our 1 to 10 system.
And it kind of dates back to the original non-digital computers where we were using vacuum tubes to store data.
Right.
So we would just have series of tubes that were either lit or not lit.
Yep.
And that represented an instruction, or that represented a number stored in computer memory.
Right. So now we're going to look at units of measurement for binary numbers. So if one binary number is a bit, then 4 bits is 1 nibble. 2 nibbles is a byte. And bytes are usually the units that you'll find more common in computers.
Right.
So a lot of times with computers, you won't measure things in nibbles because it's not really practical. I mean, you have a text file that's 4 million nibbles, it would just be sort of arbitrary. But a text file might be like 5 bytes,
And the reason why that's more common is in the earlier stages of computers, we had 8-bit numbering systems.
Right.
Because a nibble, you can only store up to the number 15, which only gives you 15 individual combinations, which is not that usable.
Right. Every byte is 8 bits. You also have a kilobyte. So one of those is 1024 bytes. And then a megabyte is 1024 kilobytes. And you start seeing this pattern of 1024, 1024. Mm-hmm. And the megabytes, gigabytes, terabytes. So when you go to look at a hard drive, that's a 80 gigabyte hard drive, or a 5 terabyte hard drive, or a 30 terabyte hard drive, you can see that 1 terabyte is 1024 gigabytes.
Which is 1,048,576 megabytes.
Right. So that means on a 1 terabyte hard drive, we have that crazy number on the bottom left, number of locations on the disk, on that 1 terabyte disk, that can either be on or off, times 4.
Can you actually, what number is that? That is, alright, we got million, billion, it's trillion. That's 8,796,093,022,208 bits. Think about how big that number is!
So that's how many are on a 1 terabyte hard drive.
That's like the United States debt right there.
So when you go to the store to buy a terabyte hard drive for $80 and you complain that it's too expensive, you're out of your mind. That's an amazing technical feat that we can have that many locations on a little platter that fits in your phone. That's crazy. It's massive.
There was like one point where it was obscene to think about, you need more than 200 kilobytes? No. You're crazy.
I couldn't imagine this situation.
I couldn't imagine this situation. Oh, I wonder if that's where that came from.
I think it was with Bill Gates and the memory limitations of Windows 3.1.
So we were talking about a minute ago with 8-bit binary. Now this is a representation of 8-bit binary. Unlike in the English language where we read from left to right, computers read right to left. If you look at the blue bar on the top, look at the exponent. The exponent is 0, 1, 2, 3, 4, 5, 6, and 7. So we have 8 values. And the base number in every single one of these is 2. Thus, it's a base 2 numbering system. So we go 2 to the power of 0, which is 1, 2 to the power of 1, which is 2, and all the way up until we get to 2 to the power of 7, which is 128. So these are the individual values that we can have in 8-bit binary. The addition of all these values equals the maximum number that we can store with an 8-bit binary number.